All right, let's see what happens inside the cooling system. So this is a conventional V8 engine, old school. I look at it and I see an old Chrysler. I can't explain why, but maybe it's just the shape of that radiator, but that's what I see. So you could see that we have a radiator, we have radiator hoses, we have a water pump, we have coolant passages, we have a thermostat, we have a radiator that goes back, we have a coolant recovery tank known as an expansion tank. We have heater hoses that go up to our heater core, right? And we have a fan. There's our pieces of our stuff. All right, so you start the car up ice cold. The coolant circulates inside the engine. We don't want it cooling yet because we're trying to heat it up, right? We want heat inside our car. We want the engine to get to operating temperature. So the thermostat opens and blocks the flow going to the radiator. So what happens is the coolant hits the pump, circulates around the cylinders, through the cylinder head, back up and around again. Now this circuit's in this too, so this will flow the coolant up to the heater core and back down, and this just gets warmer and warmer and warmer and warmer. When a predetermined temperature gets hit, this thermostat starts to open. This is known as the bypass hose. Every car has a bypass circuit, but these cars back in the older days actually had a physical hose linking it. So this thermostat opens and blocks off the bypass, and now some of the coolant starts flowing into the radiator. Well, what happens? This radiator's full of ice cold coolant. That starts flowing back into the engine, which causes this to close again. Now it continues to warm up, and it does it again. Starts letting some through, the cold stuff goes through, it slams closed again. Then it warms up again. This time period of this opening, closing, and opening, closing is known as the heebie-jeebies. You'll see when you service a cooling system and you see the coolant level rise and fall and rise and fall and rise and fall. That's what's happening. Right? So finally it warms up enough. It blocks off the bypass. The coolant flows into here. It loses temperature as the air flows through the fins. It returns back on the lower hose, goes through the block, goes through this stuff, comes back again, and cycles and on and on and on. Couple things. One, a lot of cars might have a heater control valve in this line to stop the flow from going into the heater core. Because if the air conditioning's on, why bring the temperature into the dashboard when you only want cold air? So sometimes they'll have it. Sometimes they won't. And inside the heater box is a door that blocks this off, and it's got a thermal barrier on it. Right. The other thing is, notice this valve, this expansion tank over here. What happens to coolant when it gets really hot, right? It expands, and it expands into that tank. Now, one thing we didn't mention was this radiator cap, right? That's part of the cooling system and has a tremendous influence on it. So there's a certain pressure that radiator cap will allow coolant to flow into the bottle. Now, if the system is totally sealed, then when this stuff cools down, what's it do? It contracts, and it causes a vacuum and pulls that coolant back into the cooling system. If we have a leak someplace and that vacuum goes away, then it doesn't happen. The coolant ends up staying in the bottle, and the radiator ends up low on coolant, right? So if you ever see that, look for a leak, because if the vacuum disappears, it can't draw it back. All right, so there's your cooling system stuff, right? So here we have a belt-driven fan, right? So this spins, and the fan spins and spins and spins and spins. So here's where I included some slides to show you some things, because I don't have my big crate of stuff. So here we've got water pumps. All of them are water pumps. This one is for a V engine, and it's known as a twin scroll, right? The coolant is sent into two halves of the engine at any given time. Over here is an inline engine, and you can see it's a single scroll. Only shifts to one because you have only one line of cylinders. Now, a couple other things I tried to include here. This one has a pulley, and it would be driven by a belt. This one is driven by a timing chain or a timing belt, right? See this sprocket. So we can drive these all different ways. We also can have electric ones. right? BMW uses an electric cooling pump, and that's in my big, wonderful crate of parts. And this is just showing you another one. Here's the plug, and it moves. What does an electric cooling pump do for you that a belt-driven one can't? Well, this one you can't shut off, right? But in an electric pump, we can control the speed of it, right? We could speed it up, we could slow it down, we could shut it off. So it gives you a little bit more control of moving that coolant around. Now here's a radiator. We have two kinds. We have downflow and we have crossflow. Know that the hot coolant always starts at the top, and they're not going to fight gravity, so it's going to go in the top and come out the bottom. And as it passes by, the air blowing through, all these fins that are in here, the heat radiates to the tips of the fins, and then the air blows it into the atmosphere. Now notice this one side, right? This one side is the cool side, as is the one on the bottom. You're going to see transmission coolers that are inside radiators, and that is where you'll find these transcoolers. Right now, on top of a radiator, we have a radiator cap. Now, the cap serves a very specific purpose, and you're going to see that when we talk about coolant. Right? So here we have a screw-on cap versus a push and twist cap. Here we have big caps versus little caps. They all do the same purpose. They all have a certain value where they allow coolant to pass and they allow coolant to return. Now, I want you to look at the ratings on here. So here's 15 psi. Notice that 15 psi is equal to 105 kilopascals, which is another pressure reading. Over here we have a 13-pound cap. Down here we have a 1.1 bar, right? 1.1 bar, which is also 108 kilopascals, right? So 1.1 bar equals 108 kilopascals, which comes out to about a 15.954 psi cap. If you go into all data and you use the conversion calculator, you can pull up a pressure calculation, and that will give you these values. Over here we see 88 kilopascals. Well, 88 kilopascals is about 12.76 psi, right? So you'll need to know that when you're doing this, because you're going to find a coolant pressure tester that only records in psi. So you're going to have to do this calculation and figure out what you actually are dealing with.